In this segment, we're going to be talking about multiple baseline design and its variations. In a multiple baseline design or its variations, this is true no matter which one you're using, there has to be a minimum of 2 phases in each panel. And when I say panel, you'll see what I'm talking about when I show it the graph. There'll be a baseline panel and then a treatment panel, and then it'll go below it. Going below it, and then there'll be 2 more. Those are panels. They can be across people, settings, or behavior, and they demonstrate a functional relation by repeating effects across people, settings, or behaviors. The only difference between multiple baseline design and its variations is that the data collection, the way you would go about it, is slightly different, and we'll get into that. But it's a pretty versatile design, and it relies heavily on repetition. So this will be one of those cases where the more repetition you have, the better off you'll be. So the larger number of participant settings or behaviors. Some things to know. This is a great design for behaviors that can't be reversed. So a lot, not any, I don't want to say any, but a lot of academic tasks are really good with multiple baseline design because you can't unlearn something once you've already learned it. So this is a really good design for academic tasks or things that would be dangerous to reverse. It might not be the most ethical thing to reverse an effective treatment for some really severe problem behavior. So this would be another good time. The multiple baseline or its variations would be great. But the one thing, if you want to know if there's a functional relation, you have to ask yourself, what are the chances that the intervention impacted the behavior this many times or impacted the settings, different settings this many times? So, you want to have a minimum of 3. But the more participants you have, the stronger the case you're going to make for your intervention. Now, to set up a multiple baseline design or its variations, you first have to determine if it's going to be based on people, settings, or behaviors. And then once you make that determination and you have what you're measuring, you're going to enter all of it into a baseline. You're going to enter everyone into a baseline condition. The most stable baseline will receive treatment first, then the second most stable baseline, and so on. And the treatment is constant across. It doesn't matter if it's across people, across settings, or across behaviors. It only matters that the treatment is the same across and that you enter treatment according to the stability of the baseline condition. So, of course, you would need a minimum of 3, but more is generally better. You also have to account, if you're doing research, that people will drop out. But for a multiple baseline across people, you'll need at least 3 people. But the more you have, the better. The treatment is going to be the same for whatever it is you're measuring across. And the behavior across people is likely going to be in the same response class. And you would just implement the treatment for the most stable person first. So the person with the most stable baseline, they would receive the treatment first, and then you would move so on and so forth. So that would be a multiple baseline across people. A multiple baseline across settings would follow similar rules. So you want to have a minimum of 3 different settings where you're intervening to really demonstrate a strong functional relation. And the person would be constant. So it would be 1 person across multiple settings, likely the same behavior. But you would implement the treatment in the most stable baseline setting first. So let's say you're doing an intervention in reading class, math class, and science class. Whichever one of those baselines is the most stable would receive the treatment first. And then you would continue baseline in the others until the next most stable baseline comes up, and then you would implement the treatment there, and so on. So the big idea with both of these, and behaviors too, is that the last one that receives treatment will have the shortest treatment time and the longest baseline. Now, multiple baseline across behaviors would also be 1 person, but different behaviors. It could be things like activity for daily living skills, sweeping, wiping tables, washing windows. The person would be a constant. So 1 person, 3 behaviors. The behaviors would be the thing that varied. And you would apply the same idea as the previous 2. So this might be, and again, baseline for the most stable behavior first, second most, so on and so forth. And you would just do the same thing. So here's a sample of a multiple baseline. Here's where, and this comes from ResearchGate, but you'll see what I'm talking about here with the panels. Now notice there's 3 tiers, 3 panels. Each of them has a baseline. That dotted line shows how the baseline is extended in the bottom panels. And then there's an intervention. You see the intervention is on the right side of that line in each panel. And what you're looking at here is that the most stable baseline received treatment first, the other ones remained in baseline, and then second most, and third most, and that's how you would scaffold them. So this is a multiple baseline across subjects or settings, and you notice it's math, English, and science, and notice that there's the same intervention, measuring number of responses, I guess, to the teacher in this particular case, and then the most stable goes first, and so on. So that would be what a multiple baseline design across settings would actually look like. Now, the multiple baseline also has some variations, namely the multiple probe design and the non-concurrent multiple baseline design. And those variations operate under similar fashion as the multiple baseline, but like I said earlier, the data collection is different. First, in the multiple probe design, a probe is defined as an intermittent measure of behavior. A multiple probe design uses intermittent measures of behavior across settings, people, or behaviors. Same rule as the multiple baseline design in that the first baseline is continuous, but the other two aren't. So you're not going to be collecting data like you would a multiple baseline every single session or every single day. So let's take a look at what that could look like in a minute. But the pros and cons, the nice part about the multiple probe is it does avoid threats to validity through the measure, through taking probe data instead of continuous data. And it's useful when an extended baseline is not practical. So there's certain times we don't want to extend a baseline where nothing's really being gained there and things could actually be being lost. So we don't want to do that. But one of the main cons of it is that stability issues occur. Well, how do stability issues occur? Well, any outlier in those probes is really going to affect the data path because things aren't being done every day. So here's a sample multiple probe design. And this comes from, I'm going to butcher this name, but Shipes et al. From the Journal of Applied Behavior Analysis. So you notice that in the baseline condition, probes are being done intermittently, specifically in Corey's baseline condition. Notice that there's a data point on session 11 and not another one for till right before treatment. There's a long line there. Also notice that the baseline data points don't line up for either participant. So they're not being taken the same exact days. These folks worked with one person at a time. Notice the intervention operates in a similar fashion. In the Corey Snack naturalistic teaching plus VOCA condition, you'll notice that when he first enters treatment, the researchers don't really do a treatment for Ben in that time. There's a gap, right? They're taking intermittent probes. They're continuing the intervention daily, but they're not measuring. Now, the non-concurrent multiple baseline, or sometimes called the delayed multiple baseline, the baselines are collected separately entirely. So the data points will be staggered in comparison to the other two. So by the other two, I mean the multiple baseline and the multiple probe, but baselines are not collected at the same time. So if we jump back here, what we see is that the probes are done more or less at the same time, maybe just not the same session. Whereas with the non-concurrent multiple baseline, what we're saying is the baselines are just not collected at the same time. And this is good because it's very flexible. When you're looking for participants or you're looking to help people in research, and you have two participants that are similar, but they're in two entirely different settings, a non-concurrent multiple baseline is a really good way to go. You don't need complete analysis concurrently, so you can be in both places and you don't have to do it at the same time. However, it could be hard to interpret the data because there's just different environmental variables, and it's not useful for behavior or settings. So in this case, it's good for people, but not behaviors, not settings, where multiple baseline and multiple probe can be used for any of the three. So let's take a look at what that looks like. Well, here we have, you'll notice that there's three different data points there, sets of data points. There's school grounds, there's community, and you'll notice that for three participants, there's Patty, Stan, and John. Those baselines were just not collected at the same time at all. And that's done by design. So these three people could be in three different places, and they likely are, but they're measuring the same thing. And then they had a baseline phase where Patty received treatment first because she had the most stable baseline. You could argue John at the bottom there had a stable baseline, but since they didn't do the baselines at the same time, there's no way of knowing, right? And you'll notice Stan had a little hiccup, so they went ahead and did the training with Patty first. and then they went to John, Stan, and then they went to John. So do you see how the non-concurrent multiple baseline is different? One, it can only be used with people, and two, the baselines are just done at completely different points in time. Whereas the other two, the probe and the multiple baseline traditional, are done at the similar or same times. So in closing, the multiple baseline and its variations are very common in the literature, especially in days where we deal with things that we don't necessarily want to reverse or can't reverse. And a functional relation is determined through repetition. Trend, level, stability, and latency to change all matter in your analytic tactics. You can use all of them. The big idea is latency to change. What is the likelihood, and level? What is the likelihood that repeating either across people, settings, or behaviors, that the change occurred over and over again? The more people you have, the stronger the argument can be made. So thank you for checking this one out. Hope you check out the next video, which would be changing criterion design. And as always, there's my email. Thank you so much. Have a good one.